morning, everyone. It's an honor to be here with you at this international conference to discuss one of the most transformative intersections in modern technology. So, the convergence of artificial intelligence and blockchain. My name is Khaoula Taji. I'm assistant professor at 𝗕𝗿𝘁𝗶𝗳𝗶 University in Morocco. And over the next 20 to 25 minutes, I will walk you through how artificial intelligence and blockchain are shaping the next generation of secure, intelligent, and autonomous systems. So before diving into the technical depth, let me give you a short roadmap of today's talk. So here's how we'll structure our journey today. We'll begin with a quick overview of blockchain technology, followed by a look at the evolution of blockchain from Bitcoin to blockchain 5.0. Next, we will introduce the fundamentals of artificial intelligence and then explore how artificial intelligence and blockchain complete one another. So also we'll examine common attack vectors, IA enhanced security and IA driven scalability. Then we'll explore real industry use cases, discuss research challenges, and finally look toward the future directions that will be defined the next generation of intelligent decentralized system. So to build a common ground, let's first revisit the foundations of blockchain and why it matters. So the blockchain is essentially a distributed ledger, shared database that records transactions across many computers, so no single entity controls it. Imagine a digital ledger replicated across a global network. Every transaction is grouped into blocks, which are linked in chronological order. Once added, these blocks are nearly impossible to alter without detection. That is the core idea of decentralized trust and transparency without relying on a central authority. This revolutionary design enables everything from cryptocurrency to supply chain tracking. But as powerful as it is, traditional blockchain faces real limitation when the network scales or when rapid, intelligent decision making is required. Now that we know what blockchain is, let's trace how it has evolved over time. So blockchain 1.0 began with Bitcoin, enabling decentralized financial transaction. We moved to blockchain 2.0 that introduced Ethereum and smart contracts, transforming blockchain into a programmable platform. Blockchain 3.0 addressed scalability and interoperability challenges with projects like Cardano, Polkadot, and Cosmos. We have blockchain 4.0 entered enterprise ecosystems supporting supply chain, IoT, and industry scale applications. Today we enter blockchain 5.0, where blockchain converges with artificial intelligence to create systems that are autonomous, intelligent, adaptive, and self-optimizing. Although blockchain is a powerful technology, it still faces several key limitations. Now we can talk about the scalability. Remains a major issue. Many blockchains struggle to process high transaction volumes efficiently, leading to delays and rising costs. Second, energy consumption, especially in proof-of-work system, raises sustainability concerns. Third, storage requirements grow continuously as the blockchain expands, making it harder for nodes to participate. We also have interoperability challenges. Most blockchain operates in isolation and cannot easily communicate with one another. Finally, privacy and regulatory uncertainty continue to slow down adoption, especially in sensitive or highly regulated industries. This limitation highlights the need for new approach and complementary technologies such as artificial intelligence, to unlock the full potential of blockchain. Now that we understand the challenges, let's move on to a key component that keeps blockchain networks functioning reliability, which is the consensus mechanism. So the consensus mechanism allows participants to agree on the state of the ledger. The most widely known is proof of work, which relies on computational effort to secure the network. It's robust but extremely energy intensive. Other approaches exist, like proof of stake, reduces energy use but can concentrate power among wealthy holders. We have, for example, delegated proof of stake speeds up processing through elected delegated, but raises question about partial centralization, and we have other approaches. So now each method trades off security, speed, decentralization, and cost. The challenge is finding the right balance for a given use case. So as network grow, consensus becomes even more demanding. That's where artificial intelligence can step into to optimize this mechanism. But first, a quick refresher on artificial intelligence itself. What is the artificial intelligence? So artificial intelligence aims to mimic human-like abilities, perception, learning, reasoning, decision making. It allows machines to analyze massive data, spot patterns, and make autonomous decisions. Key approach include machine learning, deep learning, reinforcement learning, natural language processing, generative AI. These capabilities have already transformed many industries. Now consider them applied to blockchain's toughest challenges. Let's explore how artificial intelligence can help blockchain directly. So in the slide, we will explain why combine artificial intelligence and blockchain. When artificial intelligence and blockchain converge, they form a powerful synergy. The artificial intelligence brings adaptability, predictive power, and automation. Blockchain brings security, transparency, and decentralization. Together, they can tackle key blockchain challenges. Scalability by predicting congestion and optimizing resources, security by spotting threats in real time, automation through smarter contract handling and reduced human error, model integrity by ensuring artificial intelligence model on chain remain trustworthy. This integrated approach helps systems scale to enterprise levels while maintaining trust and efficiency. We'll now look at the specific artificial intelligence technologies that can be applied to blockchain systems. Various artificial intelligence can be woven into blockchain to address distinct issues. For example, machine learning. We can use it for anomaly detection, fraud prediction, and performance forecasting. Deep learning for advanced security threat detection and vulnerability scanning. Reinforcement learning for self-optimizing consensus, adaptive block sizes, and dynamic resource allocation. Natural language processing to interpret legal language and automate contract generation. Generative AI to draft, optimize, and audit contrast, and even validate artificial intelligence model automatically. Each technique adds a layer of intelligence, turning a passive ledger into a responsive, adaptive system. So one of the most important area is consensus itself. So one of the most impactful areas is consensus itself, as I told. Let's dive into IA-driven improvement there. So the IA transform consensus mechanism from static rules into dynamic intelligent systems. We have the dynamic parameter calibration artificial intelligence can adjust consensus parameters based on real-time network conditions, keeping performance optimal even when loads vary. Intelligent validator selection by analyzing past behavior and contributions. Artificial intelligence can choose validators that maximize security and efficiency. Workload prediction, artificial intelligence forecasts transactions load, preventing bottlenecks during peaks. Energy optimization, adjusting mining or validation intensity to reduce energy use, while maintaining security, addressing environmental concerns. Underlying methods like reinforcement learning, time series prediction, and clustering enable these capabilities. The result is consensus that learns and adapts instead of remaining fixed. So beyond consensus, security is another domain where artificial intelligence adds a leap forward. On this slide, we bring together two essential views of blockchain security: the attack that threaten blockchain's network and the artificial intelligence-powered countermeasures designed to defend against them. Understanding this dual perspective is crucial for building resilient next-generation decentralized systems. Let's begin with the attack landscape. Blockchain networks face a wide variety of threats. We have, for example, 51% attacks where an attacker gains majority control of computational or second power and can alter the order of transaction. We also have 𝗕𝗿𝘁𝗶𝗵𝗶 attacks when an adversary creates many fake identities to influence consensus or disrupt the network. Another major category is smart contract exploits. Vulnerabilities in contract code, such as reentrancy or logic flows that attackers exploit to drain funds or manipulate outcomes. Oracle manipulation is another common vector. If external data sources are compromised, smart contracts can be forced into incorrect decisions. And in decentralized finance, front-running and 𝗕𝗶 attacks have become especially damaging, allowing attackers to reorder pending transactions to gain unfair profits. Finally, we have phishing, private key theft, and social engineering remain extremely effective because they exploit human weaknesses rather than technical flaws. This is where artificial intelligence becomes transformative. Artificial intelligence powered system can detect anomalies in real time, spotting unusual patterns or malicious behavior before the match occurs. They can predict attacks such as congestion spikes, validator misbehavior, or coordinated attempts to influence consensus. Machine learning models can continuously monitor smart contracts, identifying suspicious interactions or abnormal execution paths. Artificial intelligence validate data coming from external Oracle detection and detect inconsistencies, manipulation attempts, or out-of-range values. In addition, reinforcement learning can adapt defense strategy dynamically, strengthening the network's response as new threats emerge. And finally, artificial intelligence enhances identity and access control, analyzing behavioral patterns to detect stolen keys or unauthorized activity. Together, these measures transform blockchain security from reactive, waiting for an attack, to proactive and autonomous defense, constantly watching, predictive, and neutralizing risks. Now, we've seen how artificial intelligence strengthens blockchain security. The next step is to explore how artificial intelligence enhances smart contracts and core blockchain functionality, making the entire ecosystem smarter and more reliable. Smart contracts are powerful tools, but they still face major limitations. Their logic is rigid, making it difficult to adapt to new conditions. They can contain vulnerabilities that lead to security risks, and translating legal language into code often creates ambiguity. They also lack adaptability to regulatory changes and offer no built-in fraud detection. Artificial intelligence brings solutions to all of these challenges. With NLP, contracts can be generated and understood directly from natural language. Machine learning enables real-time monitoring to detect anomalies during execution. Deep learning strengthens vulnerability analysis, while generative AI supports dynamic updates to contract logic. Finally, reinforcement learning allows smart contracts to become adaptive and more intelligent over time. Artificial intelligence-powered smart contracts represent the next generation and evolution of blockchain automation. Instead of static code, they become adaptive systems capable of learning from their environment and responding intelligently. With self-adaptive logic, contracts can automatically adjust their behavior based on changing conditions. Artificial intelligence also improved lifestyle management by assisting in contract creation, optimization, monitoring, and even retirement. Through autonomous monitoring, artificial intelligence continuously watches for anomaly and suspicious activity, strengthening security in real time. Automated compliance ensures contracts remain aligned with evolving regulation, reducing legal risks. And finally, artificial intelligence driven dispute resolution uses stored evidence and contrast terms to help deliver fair and transparent outcomes. Together, these capabilities transform smart contracts into dynamic, secure, and intelligent digital agreements. Another important synergy is protecting artificial intelligence models themselves with blockchain infrastructure. Now, one of the most exciting things protecting artificial intelligence models using blockchain. Say you've trained an artificial intelligence to detect diseases or assess financial risk. This model is precious, but what if someone tampers with it or changes its predictions? Even small changes can cause big errors. Blockchain helps by storing model, version, and prediction immutably using cryptographic hashes like 𝗧𝗿256. Any tampering breaks the chain and is quickly spotted. Every update is recorded, creating an unchangeable history, crucial for industries like healthcare and finance. Blockchain also supports secure collaboration through federated learning, where multiple parties train a model without exposing raw data. Smart contracts can reward contributors automatically based on how accurate their models are, and artificial intelligence can monitor these models on-chain for signs of trouble. So by combining immutable ledgers with advanced AI, we create transparent and countable IA ecosystem that users and regulators can trust. Now, scalability has always been one of blockchain's biggest challenges, and this is where artificial intelligence makes a real difference. Artificial intelligence can predict network congestion before it happens, helping blockchain adjust resources proactively. It also improves how validators are selected and balanced, making network faster and more efficient. With dynamic block sizing, artificial intelligence can adjust block sizes in real time based on demand, and smart energy optimization reduce costs while maintaining strong security. These aren't just concepts. There is already powering real-world use cases, high-frequency trading with millisecond settlements, Uh, Internet of Things network handling millions of devices transactions and supply chain system processing global tracking data in real time. In short, artificial intelligence transforms blockchain into a more scalable, adaptive, and truly enterprise-ready technology. So in this slide, we'll explore the benefits of integrating artificial intelligence and blockchain. Let me walk you through why combining artificial intelligence and blockchain is such a game changer. When these two technologies come together, they don't just adapt, they actually enhance each other. First, scalability. Artificial intelligence helps blockchain handle way more transactions, which means they can finally support large real-world applications without slowing down. Second, stronger security. IA can spot unusual activity early and predict potential threats before they turn into real problems. So instead of reacting, we can stay ahead. Third, fewer errors. By automating things like contract checks and validation, artificial intelligence reduces human mistakes and keeps operation running smoothly and reliably. For more transparency in artificial intelligence. One of the big concerns with artificial intelligence today is trust. Blockchain helps by creating an auditable trail of decisions so we can see what happened and why. And lastly, adaptive systems. With continuous learning, the systems can adjust and improve on their own as conditions change. So in simple terms, when artificial intelligence and blockchain work together, we get smarter, safer, and more trustworthy systems built for the future. So theory is powerful, but real-world example shows that what's possible today. So several global leaders are already pioneering practical applications. IBM, for example, combines artificial intelligence and blockchain for supply chain intelligence. Their platform detects anomalies, improves traceability, and helps prevent contamination or waste. We have the Microsoft company uses predictive analytics to tamper-proof blockchain records in its Azure services, giving enterprises verified data for confident decisions. We have also Alibaba applied artificial intelligence and blockchain for food safety and prevent fraud across its ecosystem, protecting consumers and brands. Vici integrates IoT sensors, IA predictive maintenance, and blockchain to manage risks in manufacturing and logistics, creating reliable compliance records. This case proves that the integration is not just theoretical, it's delivering real value across industries. Yet, as promising as this is, we must also be clear add about the challenges. So we move on future research challenges. As we move toward intelligent decentralized system, several research challenges still need your attention and our attention. So first, we must address ethical concerns such as bias, fairness, and data privacy to ensure responsible artificial intelligence behavior. Second, interoperability and standardization remain essential so that different blockchains and AI systems can communicate seamlessly. Third, we face scalability issues as we discussed. So artificial intelligence computational demands must align with the limitation of distributed networks. Finally, we must improve the transparency and explainability, ensuring that artificial intelligence detection and decision remain understandable, auditable, and trustworthy. These challenges highlight the need for continued collaboration between artificial intelligence researchers, blockchain developers, industry practitioners, and policymakers. So also looking ahead, the researchers and research in artificial intelligence blockchain integration is moving towards several high impact priorities. One key direction is verifiable IA on chain, where blockchain is used to cryptographically prove the correctness of artificial intelligence decisions. Another is explainable AI, ensuring that automated decisions remain transparent and easy to audit. We also see strong interest in artificial intelligence driving DAOs, where decentralized organization can make smarter data-driven decisions autonomously. In parallel, the field is progressing toward decentralized artificial intelligence models, reducing reliance on centralized data storage and improving resilience. And finally, privacy-preserving learning, combining federated learning with blockchain, while also allow collaborative model training without exposing sensitive data. Together, these priorities aim to build artificial intelligence blockchain systems that are not only powerful but also trustworthy, interpretable, and scalable. As we near the end, let's summarize the big picture of this keynote presentation. So the integration of artificial intelligence and blockchain represents a paradigm shift. So artificial intelligence enhances blockchain's scalability, security, and automation. Blockchain also secures artificial intelligence integrity and trustworthiness. Together, they form a foundation for intelligence, decentralized systems that can transform industries, governance, and society. As we move beyond current generations of technology, this convergence will power autonomous network, Web 3.0 ecosystems, and new digital realms, where systems are not just smart, but also trustworthy and adaptable. The future belongs to solutions that are both intelligent and secure, decentralized and efficient. This is where innovation must focus. So, thank you very much for your attention. I'd be delighted to discuss any question you may have, or to explore how artificial intelligence can especially transform blockchain in your own context. Whether it's practical applications, challenges, or future directions, I'm here to provide insights. Please don't hesitate to reach out later if you think of questions or want to continue to conversation. My contact details are on the slide for your convenience. I look forward to connecting with you and exchanging ideas. And thank you so much. Goodbye.